Hello, everyone. Thank you for joining us today for this webinar on using Metaspectral's Fusion platform to get the most out of your hyperspectral data, featuring a stellar dataset from our partners at SpecTIR. My name is John, and I'm a software developer at Metaspectral. I work closely on the development and enhancement of our Fusion platform. I mainly focus on making hyperspectral analysis more accessible and powerful for users through the integration of artificial intelligence into the platform. I'm excited to walk you through the technical demo today and show you how Fusion can transform your workflow. But before I do that, I'd like to introduce you to two of our panelists today. First, the CEO of Metaspectral, we have Francis Dumais.
Hello.
And from SpecTIR, the president and COO, Aaron Kumeshat. And we'll quickly have a few words from each of them. So Francis, over to you.
Great. Hi, everyone. I'm Francis Dumais. I'm co-founder and CEO of Metaspectral. So welcome to our inaugural webinar. We hope to do many more of these in the future. So as many of you know, Metaspectral specializes in real-time hyperspectral data processing and analysis using advanced AI algorithms. Our mission as a company is to unlock the full potential of spectral data across various industries, from agriculture to aerospace, by providing actionable insights quickly and efficiently. A critical piece in achieving that is having the right tools on hand that make it dead easy to extract information from hyperspectral data. And that's what we'll be demoing for you today. From AI models for spectral analysis to large language models that allow you to talk to your data. In essence, we're leveraging AI to make hyperspectral data much more accessible. And so we're also super excited to be partnering here with SpecTIR to create an end-to-end solution for aerial spectral imaging for professionals in industries like agriculture, mining, defense, and environmental science. This collaboration means much more reliable data and quicker insights. And so you'll benefit from, first off, improved algorithms for precise measurements or material discovery. Second, the possibility of immediate processing of spectral data for on-the-spot decision-making. And then finally, a one-stop shop for both aerial imaging and state-of-the-art analysis software. That's it for me for the moment. Over to you, Aaron.
All right. Thanks, Francis. Hello, I'm Aaron Kumeshat, President and COO, joining you from SpecTIR here in Reno, Nevada. I thank you for joining our Hyperspectral Data with Fusion webinar. We're excited to join Metaspectral in this collaborative partnership and build on the strengths of both teams to create an accessible and insightful user experience. So many of you know SpecTIR and are accustomed to our hyperspectral data and analysis products. For those of you that don't, SpecTIR is the leading global supplier of airborne hyperspectral imagery. We're the first and only firm to offer co-collected high-resolution, visible, shortwave, and long-wave thermal hyperspectral imagery. The Fusion AI platform is a fresh and innovative space where our end users can interact with their hyperspectral data, while providing access to the tools to produce their own customized results and insights. Working with hyperspectral data can be intimidating, time-consuming, and expensive. SpecTIR is on a mission to make hyperspectral data more accessible and user-friendly, while enabling our customers to realize the full value of this powerful data source. Through our partnership with Metaspectral, we aim to understand the challenges you face as an end user and work together to leverage the potential of the Fusion platform. To this end, we encourage you all to explore the sandbox and provide feedback to help us develop further. So now I'll pass things back over to John Trueblood for a tour of the platform, and thank you all for joining us again.
Great, thank you, Francis and Aaron. Let me just get everything set up. Please note that at the end of this session, there will be a Q&A session at the end of the presentation. So feel free to submit any questions that you have during this time into the Q&A box, and we'll get to those as we continue. And all right. So before I begin actually getting into the actual platform, I just want to give you a quick overview of of the Fusion platform and its essence, really. So Fusion is a cloud-based platform for analyzing hyperspectral imagery, as we've established. It enables users to explore, share, label data, train deep learning models, and deploy them to run inferences. The goal with Fusion is to offer a complete end-to-end analysis solution. And we believe that Fusion is unique in several ways that make this possible. So first of all, Fusion is a fully cloud-based platform, meaning you can upload, process, and analyze your hyperspectral imagery from anywhere. So no more need for expensive local hardware. Your data is always with you. That also means no need to worry about computational bottlenecks or slow processing times. The platform scales dynamically, providing you with results fast, regardless of the size of your dataset. Now, in addition to being available on the cloud, I should note that Fusion can also be installed on-premise as well. Another aspect of being on the cloud means that Fusion allows for seamless collaboration. So that means that if you're working with colleagues that are in the same building as you or all the way across the globe, Fusion makes it easy to share your insights, your data sets, and your models. This makes it easier for teams to work together on the same projects without worrying about version control or data silos. Another thing that we're really focused on with Fusion is making it user-friendly, even for those that might not have a strong technical background in programming. The platform allows you to gain actionable insights and recommendations without writing any code. And this opens up hyperspectral analysis to a much broader audience. Fusion also allows for real-time inferences, so you can visualize and map out minerals, land cover, or other materials across vast regions almost instantly. And finally, what we'll be really focusing on today that we're very excited about is the Interactive Spectral Explorer. So you can dive deep into your pixel level data, explore, compare, and analyze individual spectral signatures, and identify key materials and geological features. So yeah, I'd like to now demonstrate some of these capabilities for you. These are all things that you're going to have the opportunity to try out for yourself in our sandbox. So here we have the first page that you're going to see when you enter the Fusion sandbox. This is the Fusion Drive. Fusion Drive is the dedicated storage solution within the Fusion platform. It's designed specifically for hyperspectral imagery. You can kind of think of it like the Google Drive, but for HSI data. It allows users to easily upload, organize, and access their data sets, making them readily available for analysis, collaboration, and model training. So we can see here that we have a data set labeled Yarrington Reference Mosaic ELC. This data set was provided to us by SpecTIR and consists of a 2-meter hyperspectral V-near SWIR image of Yarrington, Nevada. And a quick plug, while today's demonstration will focus on V-near SWIR, we'll be having another webinar in the near future focused on LWIR data. So please keep an eye out for that. So the first thing that you'll want to do when you enter the sandbox is to go ahead and open the Spectral Explorer so you can start looking at your Yarrington dataset. We can do that by right-clicking on the image and clicking Open in SpecTIR Sandbox, and that will open up the Spectral Explorer. So this is the Spectral Explorer. And before I start pressing all of the buttons and cool functionalities, I'll first give you just at a glance overview of the Spectral Explorer so that you can kind of get your bearings straight. So here at the top, we have the menu bar. This right here is the name of our project space. So this one is SpecTIR Sandbox. And what we've put here is a menu bar for people that might be more used to working on their desktops. Basically, this puts all of the tools that are available to you throughout the page in one spot. So if you ever feel like you're getting lost, you can always come back to here and find a lot of the buttons that are available in one location. Over on the left, we see that there are several subpanels, and these include the processing panel, which gives you information about the image that you're currently working with. And you can click here to see the image metadata as well. So we can open this up. We also have other panels for exploratory labels, finalized labels, reference spectra, and member spectra, masks, model results and external results that you might get from other sources. And so again, today we've got some wonderful results from SpecTIR that we'll be using to explore this data set. Over here on the right, we have the list of images in our current workspace. So whatever images you've loaded in your workspace, they're going to be listed here, and it allows you to easily go from one to the other while exploring all of them at the same time, kind of. We only have one image in our current workspace, so that's why we're only seeing this one. You can also right-click it to get some more options if you wanted to generate results from a model. We already have our model results generated, so we won't click that today. At the bottom of our page, we have the spectral signature viewer, which allows us to see the spectral signatures. There's also other tabs that allow for other tools like PCA or the ability to view your labels for regression. And finally, in the center, we have the canvas. So here we can see a false color image of our data set. And along the top is a toolbar with various tools for zooming, rotating, and selection. And I'll go over those with you actually right now. So let's say we want to start diving into this, this image. The first thing that we need to know is how to move around. So if you use your middle mouse button, you can pan the image around. And using the scroll wheel, you can scroll and zoom in all the way down to the single pixel level and scroll back out. So as we can see, this is a very rich image with lots to look at. Let's say we get really focused on one pixel and we kind of want to zoom back out and get just a centered view of everything. We can go up here to the toolbar and click Center Image. And that brings us back up to the top. If for some reason we want to look at things with a different view, we can use these rotate buttons. These three buttons here allow us to stack or organize our different results in different layouts, and I'll be making use of these as we continue to explore the data set. And then here we have buttons for if we want to regenerate the false color image, sharpen it, darken it, or if we want to change it to a grayscale image, we can do that as well. And this button here is the button that will activate our AI assistant that's built into the platform, and we'll be using that in short order. But the first thing that I want to get started with is looking at some spectra. So how do we do that? Well, we can zoom in here, and there's actually three different buttons that we can use to start getting a view of the spectra. The first one is the selection tool. So you can click on any pixel anywhere, and what you'll see is your spectra will pop up in the spectral signature panel. And whenever you click somewhere, you're going to see this modal pop up as well. And this gives information that includes both the relative location on the image, and if you, for some reason, are doing something else and you get lost, you can zoom back into that point so you don't lose your spot. It also includes geographic coordinates, and if you want, you can check those out on Google Maps as well. You'll see that as we go along, this modal will also display other information as we start to add layers. So one thing you might notice is that as I click on different pixels, the spectrum changes, and that's a feature of the selection tool. This is really just for as you're getting a handle on your data set, but you're not trying to really do anything yet. You just want to see the different spectra. Let's say you find a spectrum that's interesting and you want to save it for later for some reason, or maybe you want to label a data set for training a model. That's the point selection tool. And how this is different is that when we click a point and it gives us our spectrum, now it's going to stay over here in the exploratory labels panel. So here's our selection that we've made, and we can hide it if we want to or bring it back up. And as I said, the difference between this and the other one is that if we make another selection, now we have both of those spectra, and we can do this as many times as we want. Although in the sandbox, you'll be limited to 5 selections. So if you do hit that limit, an easy way to continue exploring is to just take one of your selections and right-click it, and it'll open up this context menu, and you can remove them so that you have more space to work with. And finally, the third way is with the lasso selection tool. So what we can see with the lasso selection tool is that we can draw selection and get that spectrum. So let's see, what's this? Okay. All right. So yeah, as I said, that is this is the spectral signature panel, and if you've ever worked with Spectra, it's pretty straightforward. We've got the ability to see the wavelength, the intensity as a function of wavelength. If we want to zoom in on an area, we can either use the scroll wheel. It's probably going to be more interested in this area with minerals. And if we want to pan, we can use the left mouse button. And if we need to zoom back out or reset our zoom, we can use this button here. We can also use this specific zoom select if there's something that we really want to see. And again, we can zoom back out. Another thing that I should point out is that we have this workspace settings button here. So this allows you to configure several options throughout the workspace. So if you feel like there's something that you want to be able to tweak, chances are it might be in this area, especially if it's related to spectral signatures. So one thing that I want to point out is that you do with selections, it's averaging the spectra across all of those pixels. If we want to see all of the individual spectra, we can click this button and it will load those for us. So there we go. All right. But for the sake of keeping things simple and not getting overwhelmed, we'll go back to that average spectrum. So now that we have a basic idea of how to do exploration in the sandbox, in the Spectral Explorer, let's start to actually see what we can find out. So if we click this Fusion AI button here, it's going to bring up the AI assistant. Now, this is an integrated multimodal AI that can process both text and images. It can handle user data and can hook into the various tools that are available natively in the platform to perform automated actions. Additionally, from time to time, it'll present you with some highlighted clickable text that takes some kind of action when you click. So let's say it's already run principal component analysis. If we click that, it's going to open up the PCA plot. And one cool thing about the PCA plot is when we've got a selection, if we click on it, it'll show us which points within that PCA plot have that selection corresponds to. And if we need to find our selection, we can double click on it and it'll bring us back to that location. All right, so let's see how we can use the AI to help us explore this data set. Now, my keyboard is really loud, so I'm going to copy and paste the sentences so that you don't have to hear me clacking on my keyboard. And I'll read out loud what I'm saying. But again, the responses that we're getting back are not scripted in any way. These are true responses from the AI. So it said, I'm not a geologist, so you need to keep this stuff simple for me. I want to identify areas of copper mineralization. I have mappings of the end members, and I have a classification model that shows me various species. I've heard porphyry skarn alteration is most prolific in the Yarrington region. Can you tell me more about this? So it's telling us about Yarrington, the rock type, copper association, and it's telling us to look for some specific minerals associated with porphyry skarn alteration, but this isn't really giving me much, so maybe I'll ask it to tell me more about this type of alteration. So all right, so porphyry skarn alteration occurs when hot mineral-rich fluids from a cooling magma body interact with surrounding rocks. If you're a geologist, this is bringing you back to your 101 course, I'm sure, but this is new to me. Let's see if we can find something. Okay, so now it starts to talk about indicators in our data. It starts to talk about these end members that we have. So there's some chlorite, some muscovite, and kaolinite that might be related to copper mineralization in our region. So it's recommending that we start to look for some of these things. So what we can do is start to explore these. So let's start with the kaolinite. We can go over here to the left and open up our End Members panel. And this will display the end members that have been identified in this image. So here we have the kaolinite spectrum. And let's open this back up. And when we click on this and make it viewable, we'll see the end member spectrum of kaolinite. And again, we can hover over this and get an idea of what we're looking at. Now, let's say we want to make sure that this matches with the expected signature that one would get from kaolinite. In order to do this, we can open up the reference spectra panel and load this. And here we see kaolinite has been preloaded for us. And if we make it visible, all right, so that looks like a pretty good match. Now let's see, where is kaolinite in our, where is this end member located in our data set? So I kind of just zoomed out and this just appeared. I'll show you how that happened. Is when you click on one of these eyeballs to make your end member visible, it's going to show the end member mapping. So I'm looking around and I see up here that there's quite a strong region of kaolinite up here. And we can put this on top of our image, and let's go ahead and make a selection here just to see what this looks like. I'm not good at drawing. All right, so let's see, that's this one. If I hover over this exploratory label that we've just made, we can see it down there in the spectral graph. So that looks like a pretty valid signature there. Okay, that's cool. Let's go ahead and hide these and see what else we can look for. So the other one that it said is chlorite. So if we bring up chlorite in our end members, again, we get the same thing. So here we can see the mapping of that. But you'll note that there is no chlorite in the loaded reference spectra. So we have to load that in, and we can do that using the spectral library. And we can search for that. And just to note, while we do have some several libraries already filled, you can bring in your own, you can import your own spectral libraries. So let's take a look for the chlorite HS197. I'll open this one up and we can add it as a reference. Okay, good. So that end member seems to be lining up quite well. All right, so let's say that we've used this so far to kind of help us out in creating a model, and we've got an idea. So as I said, we've got some external results from SpecTIR, but we also have a model that we generated, a classification model to see where the mineralization is on this data set. So what I'll do is overlay, actually I'll put it next to it. There we go. So now we can see the results of the classification model, and we can see how well these are lining up with the end member that we're looking at, which is chlorite, right? Chlorite. So if we open this up down here, we can see, okay, we're looking for this pink area. One thing we can do if we don't have the best eyesight, like myself, is we can click on different regions to see what they relate to. So when I click on this spot, you'll note that the modal that pops up is telling us, okay, this is illite. Great. So again, this is like a pink color, so we can see, okay, there's our chlorite. So all these pink areas are chlorite, and that seems to be agreeing. There's that dark area here where there isn't any. All right, that's interesting. So now that we see that this is here, maybe we want to get a better idea of a semi-quantitative idea of where this chloride is. So now we can load up these external results that we were provided from SpecTIR. So we're going to overlay the chlorite rule data. Now, obviously this is quite washed out. So what we're going to do is we're going to use thresholding. So we can go over here underneath the chlorite panel, click on threshold, and we're going to stretch the histogram. So we'll make the minimum 0.90 and keep the max at 1. And this stretches out our histogram. And then in order to turn on thresholding, we'll click this button, this button right here, use confidence thresholds. And now we can see that this threshold has been applied to the chlorite results. And that's great. Okay, so we can see here that this is where we've got that strongest signal for chlorite. So now we've really focused it in even more. And what I'm going to do is actually, just because this is always fun to do, is I'll hide this. That I just hid the end members. So now we've got our classification model results and our rule data. And if we overlay these, and reduce the opacity of our model results, we can toggle this. Let's bring this back up a little bit. There we go. That's cool. Okay, so we can see, yeah, there's good agreement here. All right, so let's split these back up again. And we think I mean, these two areas right here, this loop kind of seems like a good area to start focusing on, which again, that makes sense. So let's bring this back up and let's start looking around. So yeah, I'm seeing in this area that there's these pockets, these kind of pockets of, what do we have here? Chlorite, obviously, and this is dolomite, and this is calcite. And there's several areas like these little bullseyes that we're seeing. Calcite, chlorite, dolomite. There's another one down here. Okay, so I don't know what that means. Because again, I'm not a geologist, so I'm going to tell the AI that. I'm going to say that after taking the AI's advice and looking at these specific end members, what did I find? I found a few areas of central bullseyes of calcite and dolomite surrounded by a broad area of chlorite. There are several areas like this, and the dolomite and the calcite seem to be mixed, such as right here, while the chlorite is kind of spread out around them. And I'm just wondering, is this useful? It is very useful. Thank you, AI. And potentially significant for identifying areas of interest in your copper exploration efforts. Let's break it down. The presence of calcite and dolomite in the center suggests a carbonate-rich core. This is often indicative of the central part of a skarn system. The mixing of calcite and dolomite could indicate complex fluid rock interactions, which is common in skarn formation processes. And it talks about the different alteration mechanisms. This is highly characteristic of skarn systems associated with porphyry copper deposits, where the transition from the carbonate-rich core to the chlorite-rich periphery often marks areas where metal precipitation can occur. The fact that you've identified 3 such areas is particularly interesting. These areas should be high priority targets for further investigation. Okay, that's good to know. And the zones between the carbonate core and chlorite halo are often the most prospective for copper mineralization in skarn systems. All right, sounds like I've hit pay dirt. Let's continue to look at this then. So I have all of these results from SpecTIR. Right? We've got rule data, mineral analysis, index data. Let's open mineral analysis and we see chlorite chemistry. Okay, so maybe you're not sure what to do next. So like myself, so I'm going to tell the AI basically, what should I do next? I'm going to ask the AI. I have mineral analysis results of chlorite chemistry showing magnesium versus iron, as well as chlorite crystallinity, which is what we've got here, these two. I also have some analysis for iron. Tell me the most useful thing I can look at in terms of this while further investigating these bullseyes. So hopefully this will give us some more guidance. And while we, okay. It will provide valuable information. Let's focus on the most useful aspects of chlorite chemistry, crystallinity, and iron mineral analysis. The magnesium to iron ratio in chlorite is crucial for understanding the alteration environment. It indicates proximal alteration. The magnesium does, while iron-rich chlorite is typically associated with distal. In your bullseye areas, map that distribution. Areas with higher magnesium content might be closer to potential mineralization centers. Okay, that's a good note to make. Higher crystallinity in chlorite generally indicates higher temperature formation or more intense hydrothermal alteration. So again, focus on areas where chlorite shows higher crystallinity, as they might have potential mineralization. And then it goes on about iron mineral analysis. I'm gonna just do this because this sounds like a great start. So let's go ahead and try that. So let me hide this. What I'll do is close the rule data and I will open up chlorite chemistry. All right, and can we? We'll hide this, and I also want to hide my rule data for now. All right, great. So what we see right now is the chlorite chemistry ranging from magnesium in the purple to iron in red. And why don't we go ahead and set this to grayscale so it's a little bit easier to see the colors. Okay, there we go. And what we can do is toggle classification results on just to make sure we're in the right area. Okay, that's good. So there's some there. So this looks like an area of high iron. And over here and here, it looks like we've got more of this magnesium. And let's also look at the crystallinity as well. So again, it was saying high crystallinity and high magnesium. So if we toggle our chlorite chemistry on and off, so we toggle it off, and now we can see, I'm sorry, the chlorite chemistry on and off. Here we see the chlorite crystallinity. So up here, there's high crystallinity, and there's some pockets in these regions. So let's toggle this on and off. We're looking for blue. So again, this area is showing us that we've got magnesium chemistry, relatively, and relative high crystallinity. All right. So let's go ahead and tell the AI that. So what I said, the chlorite rule data overlaps well with the bullseyes, as we already saw. I see around the dolomite calcite bullseye, there's areas of magnesium chlorite. I see other areas that have more iron-rich chlorite, though. The areas of higher magnesium seem to be have higher crystallinity. Does this mean anything? The overlap of chlorite with dolomite calcite bullseyes is indicative of a zoned alteration system, which I think we've spoken about already. Let's see the magnesium-rich chlorite. The presence of this magnesium-rich chloride is particularly interesting. Magnesium-rich chloride often indicates proximity to mineralization. So I'm ready to go in here and start looking for some copper. The iron-rich chlorite typically forms in cooler, more distal parts of the hydrothermal system. This distribution suggests a temperature or chemical gradient in the alteration fluids. Higher crystallinity in magnesium-rich areas indicates higher temperature formation, more intense hydrothermal activity, and potentially closer proximity to the heat source. And in terms of mineralization, the magnesium-rich, highly crystalline areas are associated with favorable conditions for copper mineralization. All right, and we can go on. So hopefully at this point, you're starting to get a taste for what you can do here. I'm sure there's plenty more questions that could be asked, things that you could explore here. I've only shown, I think, 3 of the various external results that SpecTIR has provided to us. So there's a lot that can be done. So hopefully you guys can really dive into this and see what you can find. I haven't even brought up the ability, I've brought it up, PCA. We won't get into that. And material identification. So let's say you go to Spot, you could right click and you could do identify material. And if you click this cog, you can open up the window to set which spectral library you want to use and the wavelengths that you want to filter by. So there's a lot more here that you can play with. So there's one last thing that I want to show you before we move on, which is the model page. So let's say that you're using Fusion to train models, such as this Yarrington classification one. We can right click here and we could go and view the data set that was used to train this model. We could also go look at the model itself. So let's go ahead and take a look at how that went. So this is the model training page, and it gives you an overview of how the model was trained and how it did during that training. So we've got the validation matrix, no test runs, summary of the scores, a loss function, and our accuracy. And we can also see the dataset metrics, the dataset that was used to create all of this. So along with the configuration of the model. So again, a lot to explore here. So that's all I have to show for right now, but hopefully you have a sense of how to use Fusion and you're excited to get into the platform. Let me bring up the PowerPoint slide and just give you an idea of what we're going for next. So this is the vision that we have going forward from what you've seen. Where we came from is phase one with the building of the platform. It's cloud-based data sharing, visualization, and deep learning powered analysis. We're currently in phases 2 and 3, which is the addition of more classical analytical methods. As you saw, we've got PCA, end member extraction, material identification, but we want to keep adding more of these so that they can be used alongside these deep learning models that we provide access to. And also, as you saw, we're working on the integration of this AI-driven assistant. So you can have embedded conversations, and we've built this infrastructure that gives the AI real-time access to user actions, models, and data so that you're not having to type in all the time what's going on. It just knows what's happening. And really what we're focusing on is this methodical development of automated task sequences. Building this kind of AI solution is not something that you can just bolt on to the existing software. It needs to be done in a methodical way, one task at a time. And as you probably noticed, that it had quite a bit of knowledge about, the AI had quite a bit of knowledge about this domain area. And we're working on building intelligent retrieval systems to get relevant scientific papers so that each use case, it will have the most relevant information. And where we're going with this in the future is the goal is to get a full AI expert integrated into this system, and the entire workflow will be automated. So instead of me having a conversation with the AI like you saw, it'll just be that first message that I sent, and it'll do everything that you saw me doing. And that's going to be a lot of work, but we think we're well on our way to getting that done. Now, let me make sure I have not forgotten anything. So we've gone over the Spectral Explorer. We've gone over SpecTIR's results that they sent us. I encourage you to go explore that data set in the sandbox for yourself and see how it feels. Please don't hesitate to give us any feedback. We want to know what you think. We want to make this product better for you. So here's the link to the sandbox. And again, any input you have is greatly appreciated. We want Fusion to meet your needs, and we want to deliver the best experience possible. And if you have any questions at all, whether it's about the platform or whether it's a business case, you can reach out to Francis or Aaron at their emails that are listed here. And again, before we start to take questions, I want to inform you once more that we'll be having another webinar in the near future. So please keep an eye out for that. And with that, I'll bring back in the panelists and we can begin the Q&A session. Thank you. And all right, looks like we've got some questions. So the first question is, can you show us how N members are actually generated? What algorithms can be used to generate these? So that sounds like a good question for Guy to answer.
Yes, so we have the N member on the platform were already generated, but we can generate them. We can generate them on the platform, and there is two algorithms available. We have the N finder algorithm, and we have VCA, which is Vertex component analysis.
Great. Thank you, Guy. Next question is, what classification model was used? That might also be you, Guy.
So the classification model, it's a deep learning model that was trained on the Fusion platform. So yeah, at the end, John showed you the page where there is actually another tab on the platform. We didn't demonstrate that, but where you can build a data set and create a model and train it on the platform. And then you can generate the inference on any image you want. So yeah. That's how we need it.
Yeah, we can add maybe a bit more over there. That a lot of our IP is in the architecture of the neural networks that we've come up with. They're specifically designed for hyperspectral analysis in the spectral domain, obviously. And so we have we'll be holding a webinar in the near future doing a deep dive on that part, but on that model page, when you're ready to train your model, you have the option to select from a few different architectures. Some of the most recent ones, for example, include transformers, where we've kind of taken that concept that was popularized by large language models, and we've adapted it to hyperspectral analysis. And those are some of our most or best performing models to date.
Great, thanks, guys. Feel free to continue asking questions as we go. I don't think the Q&A session is closed, but yeah, I'll continue. Next, we have the question that says, "What is the LLM you use behind Fusion AI?" So actually, initially we were using the ChatGPT API. We've recently switched to Anthropic's, so we're using Claude. The way that we developed it is so that it's agnostic, so we can switch between different providers as they jockey for position in that industry. And another thing that we're looking at is training our own large language models so that they can be even more domain specific to our use case. Okay, the next question is, can crystallinity be calculated on the platform, or does it require external inputs from SpecTIR? So I think, would that be an answer for would that be for Guy? Or that might actually be Aaron.
Yeah, right now, I don't believe the platform has the capability to produce those chloride crystallinity results, but that's something that we could potentially work with Metaspectral to develop. It's not that complicated of an algorithm.
Yeah, sorry, I guess I shouldn't have sent that over to you, because you then had to answer for our platform. But yeah, I guess the results that we showed today came from SpecTIR, and yeah, we think it'd be cool to add that ability into the platform for sure. Guy, did you want to add anything, or is that?
No, yeah, that's what I wanted to say. Yeah, that's today
Okay.
we use the result from SpecTIR. Yeah.
Great. All right, let me just continue forward. This is wonderful execution of identifying minerals. Is it reliable for a specific region or applicable in all regions? It's a good question.
The next question is
Yeah.
a follow-on. You just want to read that?
Oh, sorry. Okay. Because weathering in rocky area depends on rainfall intensity. Okay, good catch.
So do you want me to take that, John?
Yeah, sure.
Yeah. So based on what we're seeing here, we believe this will be very effective especially in arid regions where we typically collect hyperspectral data. we've got a very refined workflow that makes our data quite repeatable and consistent. So we believe that the robust nature of the platform will be able to handle lots of use cases. So we're super excited to start pumping in different use cases across minerals and environmental work in vegetation and water studies.
Okay. Next question is, can we use your platform for spectral and mixing?
So
I'll let whoever wants to take that can feel free to take that one.
Yeah. So well, the answer is absolutely yes. We have so I mentioned different model architectures, but then we also have different model types. And so the most basic version is classification, which is what you saw today. But we also have AI models that do perform spectral on mixing. And we have applied it to some mining applications as well. And we are also using them in some other industrial deployments, processing data in real time. So yes, there's definitely that option within the Fusion platform.
All right, next question is, I think they're just asking if we can expand upon the uncertainty of the models that might be used, if there's any uncertainty metrics or how we address that.
I guess that would vary by model, right? Well, the actual metric would vary by model, but
yeah, maybe this question, if whoever wrote it wants to expand upon what they mean, and then we can come back to it. And then we'll continue forward for just this moment. So how do you get the source information being produced from Fusion AI? How do you ensure the scientific rigor of the resource? Absolutely. Like, as we all know, hallucination is definitely an issue at this stage with large language models. The key to this is, I guess, there's a couple things that we do to make this possible. One is through retrieval augmented generation. And what that involves is, as I said in the vision slide, is basically building a system for the AI to access scientific documents that it can then use to answer the question, and telling it that it can't answer without having some kind of reference in that paper. That's not going to 100% of the time always guarantee. Like they're until that architecture's solved, there will be some instances where there is hallucination, but we find that by using this augmented generation technique, it really reduces the amount of hallucinations and increases the usefulness of the information that it's giving us. And we're currently working on some really cool techniques to improve that retrieval process, so that it's really specific to your use case. And that's what I'll say for now. Can you process radiance is the next question. Guy?
Right now, not, at least not for airborne data. But that's something we would like to add in the future. If you acquire data in the lab, we can, with the right reference, then you can do you can go from radiance to reflectance on the platform.
Sorry, I just want to clarify. If the question is, can you convert radiance to reflectance, then Guy's answer is correct. But if the question relates to can you train models, can you upload data in radiance and then train models directly on radiance, then yes, absolutely you can. And we've done that specifically for to measure, for example, concentration of greenhouse gases.
Awesome. Next question is the user able to generate these outputs or classifications themselves, or is this done by the Metaspectral team and then provided as an output to the user? So for this specific sandbox, we've generated the classification model. And in the sandbox case, the training and running of models is restricted because that's quite computationally intensive. But as a user, the platform does allow you the ability to train and run your own classification models or other types of models as well. So the answer is yes, I guess. Yeah. Does anybody want to add anything to that?
Yeah, but like the user absolutely has the ability to create their own data sets, train models, everything, all the data you upload, and all the models you create are your property. We do not have access to them and do not use them for subsequent training. Of course, we do have customers who do ask us to train models on their data, and so we always have that option if required.
Thank you. Next question is, do you have any metrics on processing speeds relative to other software like Envy? It's a good question. We definitely strive to make the processing speeds as quick as possible. I don't know, I myself don't know of if we've done any specific benchmarking so far.
Yeah, I would just like to highlight that we everything that you saw on the platform today is or the focus of it at least is AI-based algorithms. And so by nature, these are high complexity algorithms that are able to extract more signal from the data and therefore achieve a much higher accuracy. And so because they're higher complexity in general, they would take more time to run than a low complexity algorithm like adaptive cosine estimation, for example. However, we do have data pipelines in place to automate the analysis of data in real time if there is that need. And so, for example, in our industrial applications, we are processing over a gigabit per second of data using AI models pixel by pixel in real time.
Thank you, Francis. Are there any other questions that anybody would like to put forward?
If there is no, I would like just to add, because there was a question about uncertainty, and we didn't show that, but when we do the n-number extraction, actually it gives a percentage of confidence for the top 3 n-number that it extracts for each, well, the top 3 identified n-number, because we compare the n-number to a spectral library. And so for each n-number, it gives the top 3 match of the spectral library. And for each of them, we give the percentage of confidence. So there is some kind of uncertainty measures there.
And on the AI model side, I would say we measure the false positive rate and the false negative rate, which of course translates into precision recall and the F1 score.
Okay, I'll just mumble about while I wait to see if any other questions roll in. It looks like there's no other questions. So with that, I just want to thank everybody again for coming today. We're really excited to have you guys try the platform. We look forward to any feedback you might have, and please feel free to reach out to us at any time. Does anybody else want to say anything? No? All right.
Just going to say that this webinar is recorded, and so we are going to make the recording available to attendees.
Yeah, thank you for that, Francis. Yeah, we will have this recording on YouTube. Okay. Thanks, everybody. Have a wonderful day.
Thanks, everyone.
Thank you.